Good morning, everyone. Today we'll be discussing the problem rectangular tiling, which came in Starters 92, which happened on 31st of May 2023. So let's see the problem statement. The problem statement goes like this. You have a rectangular floor R with width W and length L. You want to tile this floor with some rectangular tiles R1, R2 such that Rk, where k is greater than or equals to 1. But you want to tile it such that I varies from 1 to k. The width and height of Ri is a positive integer and Ri has a perimeter which isn't divisible by 4. Note that different tiles can have different heights and widths. You need to find out whether this is possible to do so or not. This is a kind of problem where we just need to print yes or no. These kinds of problems are pretty easy, and we just need to find out that in which case it is not possible, because we can, if the height and width of the rectangular tiles can be different, we can always tile the constraint that it is given that the perimeter of each tile should not be divisible by 4. Let's look at the problem statement a bit more closely. So let the floor have the dimension a comma b. Okay. Uh, Pardon me for the handwriting, but you get the idea. A and B. A has two choices. Either A can be even or A can be odd. Okay. Similarly, B also have two choices. Even or odd. The formula for perimeter is 2 into length plus breadth. Any number is divisible by 4 if it is twice divisible by 2, right? Every perimeter is always even as 2 is multiplied. So if we ignore this part, the multiplication of two part, we just need to make sure that A plus B, or the Li and Wi, that is the length and the breadth of a particular tile, should not be even. For A plus B not to be for Li plus Wi should not be even, right? So to achieve this, we need to make sure that Li and Wi both can't be even and both can't be odd, right? If A and B are of one is even and one is odd, that is A mod 2 is not equals to B mod 2, then we can print yes, right? That is, if one of them is even and the another one is odd, then we can take the tile of that dimension only and tile the whole floor at once. Okay. To check this, we also know that k can be equals to 1. Moreover, if both of them are even, let's say we take any two even numbers x, y, right? Our goal is to divide one of them into two odds. Did you get that? If we are able to divide x into two odd numbers, then we can use two tiles, of which one of them has an odd length and y can be y, as y is already even. So let's say x is 2 and y is 4. We can divide 2 as 1 comma 1 and take 1 comma 4 and 1 comma 4 tile to cover the floor having dimensions 2 comma 4. Correct? But if x and y both are odd, we can't divide them as the sum of two even numbers. Correct? If we take out an even chunk from an odd number, an odd number is left always. It is a basic ideology. So we get a constraint that If both of them are odd, we have to print no. If both of them are even, every even number can be defined as the sum of two odd numbers. So we can print yes. And of course, if initially both of them are of different parities, that is even odd, then we can already print yes. Let's code the solution and let's get rid of this. And okay, here I have taken the number of test cases as input initially. So this is A and B. Here we take input A and B, and as we discussed, if A mod 2 is not equal to B mod 2, we can print yes. Otherwise, if A mod 2 is equal to 0 and B mod 2 is equal to 0, then also we have to print yes, otherwise no. Okay, let's check if we have coded it correctly. Let's first run for the given sample of test cases, which should be yes, yes, no. Okay, okay, we have a correct output. Let's say if it passes all of the test cases. Yes, we have completed our question. I hope that I was able to convey the correct solution. And if you all have any doubts, you can always ask in the comment section. Thank you.